All right, welcome to day 3 of exponents. Today we're going to learn some more properties of exponents. Yesterday we did scientific notation. Remember, we have basically 2 properties in our toolbox right now. That is, anything to the 0 power is 1, and negative exponents go into the denominator and become positive. Well, today we're going to learn about the product of powers. So let's start here and look for a pattern. Remember, x to the 3rd power means x times x times x times x to the 4th power, which is x times x times x times x. How many x's do we have multiplied together here? Well, it looks like 7 all together being multiplied together. Similarly, 8 squared is 8 times 8. 8 to the 4th is 8 times 8 times 8 times 8. All together, we have 6 8's being multiplied together. Finally, x to the 5th is x times x times x times x times x times x squared, right? Here's x to the 5th times x squared. All together, we have 7 x's being multiplied together. Well, if we go back and look at our exponents, 3 and 4 make 7, 2 and 4 make 6, 5 and 2 make 7. To get our answers, we are adding those exponents. Notice if you have the same base, like we had in our examples here, to get the total number of numbers being multiplied together, we add those exponents together. Well, let's look at some examples. So, again, anytime you're watching the video, you can always pause it, do it ahead of me, and then play to check. So here we have the same base. 3 plus 7, 5 to the 3 plus 7, 5 to the 10th. We got 10 altogether. All you need is the answer. Don't have to write the in the middle. Remember, invisible 1. So our exponents here are negative 3 plus 6 plus 1, which is going to give us 4. So our final answer is x to the 4th by adding our exponents together. Here, 4 plus negative 4 is going to give us 0. Remember, our answer is not 0, but it's x to the 0, which means our final answer is 1. Tricky question. Don't be fooled. Now, here's where it gets a little confusing, and that is, remember our new rule refers to exponents, but not the coefficients or numbers in front. So if we want to simplify this example, A, we do 5 times 3 is 15, but now when it comes to the x's, we add the exponents to multiply them together. Here we have 3 squared is 9. So we're going to have 9 times 2 times 4, which is going to be 72. Now, also, we have to make sure we're combining things that are the same. Notice x to the 4th and x squared can combine, and that's going to give us x to the 6th. But then here, that y, that's my only y. So y cubed, that would be my final answer. Don't just add all the exponents together, but only the exponents that have the same base. So the x's and the y's, they don't combine. Finally, this one, we're going to multiply 2 times 6. And then 6 plus negative 4 is going to be 2. So x to the 2nd power. When it comes to quotients, well, let's take a look and look for a pattern. Remember, 8 to the 5th means 8 times 8 times 8 times 8 times 8, divided by 8 to the 3rd is 8 times 8 times 8. And so when we divide, remember you can cross like 8 divided by 8 is 1. So we can cancel all these out, and you can see we have 8 squared in the top, or 8 times 8, 8 squared is left over. Similarly, this is 1, 2, 3, 4, 5, 6 x's in the numerator, 2 x's in the denominator. Those 2 cancel with those 2. We're left with x to the 4th. For this one, we have 2 x's in the numerator, 1, 2, 3, 4, 5 in the denominator. Those two cancel with those two. We're left with 1 over x to the third, or x to the negative third, right? This is the better way of writing it. That's the simplified way, no negative exponents. But if we were looking for a pattern here, notice 5 minus 3 is 2. 6 minus 2 is 4. 2 minus 5 is negative 3. And that is our rule. When we divide, you can subtract the exponents that have the same base. Again, these are both a, right? Same base. You can subtract the exponents. So you can do it either way. You can subtract the exponents, or you could think the way I did it and cancel out. I like the canceling out because things just stay where they need to be. So here, 10 minus 5 is 5, or else I canceled 5 in the bottom with 5 on the top. Either way, z to the 5, or fifth, is my final answer. Similarly, 6 minus 10 is negative 4. Or you could think these 6 cancel with 6 of those. Either way, that is my final answer. Here, there's a couple ways you can do this one. One way is to rewrite everything so that there's no negative exponents. In other words, that's going to go down and that's going to go up. So we're going to have y cubed, y to the 4th over x times x to the 5th, which would be y to the 7th over x to the 6th. Or we could have done negative 1 minus 5 for the x's. Notice that's negative 6. And we could have done 3 minus negative 4, subtracting the y's, which is positive 7. So whether you just regularly subtracted the exponents or rewrote it the way we did. For this last one, we have these 4 could cancel with 4 of those, or in other words, 4 minus, oops, I'm thinking of the answer, 4 minus 9 is negative 5. Either way, we get 1 over b to the 5th in the denominator. For E, 4 minus 2 for the b's is going to be b to the positive 2. Negative 1, oh, I'm sorry, not negative 1. 1 minus 4 for the c's is negative 3. So b squared c to the negative 3, which is b squared over c to the 3rd. That's our final answer. Again, that 1c could have took out one of those, right? And you could see you'd have c to the 3rd in the denominator. Or those 2 could cancel with 2 of those. However you want to look at it. Now, these totally cancel. Remember, that is 1, not 0. 1. And then here, they could flip-flop places and become positive. Or you could have done negative 4 minus negative 3 for just subtracting the exponents and get negative 1. Either way, it's 1 over b, or 1 over b to the 1. You can put the little 1 there. It doesn't matter. All right. One more rule, and that is the power of a power. Well, let's look for a pattern again. Remember, if something's squared, it's times itself. So this is the same as x cubed times x cubed, which is x to the 6th. This is y to the 5th times y to the 5th times y to the 5th, which is y to the 15th. This is z to the 4th times z to the 4th times z to the 4th, which is z to the 12th. Notice here, 2 times 3, 6. 3 times 5, 15. 4 times 3, 12. And that is the rule we get right here. When we have an exponent raised to an exponent, you multiply. Well, let's look at some examples. Again, you can always pause it, do it first, then check it with me. So 3 times 6, this is going to be x to the 18th. Negative 4 times 3, this is x to the negative 12th, which is 1 over x to the 12th. Always write your answer with positive exponents. Negative 2 times negative 4, x to the 8th, positive 8th. This one, ooh, this is two things. So we're going to write that first part first, but simplify that. So that's going to be c to the negative 6th. Now when we add the exponents, we get c to the negative 1, which is 1 over c. That's it. Simplifying this part, that's going to be n to the 20th times n to the 5th times that. And so n to the 25th is our final answer. Simplifying this, that's x to the 10th. Simplifying that, ooh, that's just 1, isn't it? Anything to the 0 power is 1. So that is our final answer. And that, yes, is it. I thought that was it. So remember, your final answer should fit all these criteria. No negative exponents. Everything should be simplified, like you shouldn't have two x terms or two a terms. Same base does not appear more than once. All parentheses, no powers raised to powers. There shouldn't be any parentheses in your answers. So all of these here are good. Those are happy face, right? Those are all good looking answers. These over here are not good looking answers. Notice there's two A's there. That should be simplified. Or two X's. That should be simplified. We shouldn't have a parenthesis or a power raised to a power. No parenthesis. No parenthesis. Here, the 10 and the 4 could be simplified. That wasn't simplified. So that is it. Oops.